learners, welcome to Education Online program. I'm teacher Willa Lucia. In our previous lesson, we talked about the motion under gravity, where we say there are two types of motion under gravity. One is the free-falling object, and the second is the projectile. But we basically talked about the free-falling objects. So, where we say that the mass of this object does not actually affect its motion, and even when you're talking about the motion under gravity, we have to neglect the air resistance and the friction. We only want when the body is being affected by only the force of gravity. So since we saw so many equations, the three equations for the vertical upward movement of the body, or the downward movement of the body under the action of gravity, we are going to be using all those equations today. We shall look at them, how we are going to be using them. So let's take a look at this. We shall start with an example, which is saying that a stone falls from rest from the top of a high tower. Calculate the velocity after 2 seconds. So you see, let me put it down, saying that a stone falls from the top of a high. From the top of a high tower. Calculate the velocity after 2 seconds. So if you look at this, the stone is falling from a tower. Assuming that this is your tower, let's have something like a house. So we're assuming this is our tower, and the stone was somewhere right here. So this stone has to fall from this tower. And they're saying that it fell, calculate the velocity after 2 seconds. So when the body was falling after 2 seconds, what happened? Because at this point of the cliff here, of the tower, there was no timing here, because here the stone was at rest. So now, how would you find the velocity attained by the body when it started falling from the top? For you to know the velocity, you need to know the timing. So if you have this time, so what was the initial velocity with which the body started falling? Because now what we are trying to find here will actually be the final velocity, the velocity the body attained later on after the 2 seconds. So let's take a look at this. If we are saying that at the top of this tower here, the body was not moving, it was just placed there, the stone, that means that at rest, the initial velocity given to this body was 0. So if we have our initial velocity u is equals to 0 meters per second, they're saying that velocity after 2 seconds. So the timing here, we are timing that what if the stone moved for 2 seconds? What speed, what velocity was the stone moving with? So to get that, it is the v we want to know, which is more like the final velocity attained by this body after leaving the top of the tower. So let's look at this. Now from here, for you to get this velocity, you need to know the acceleration. At what rate was the body accelerating? Because our body is falling from up, we see that there is action of gravity acting on this body. So this body is moving with an acceleration known as the acceleration due to to gravity. So instead of us having the A, we have our G. And what is the value of this acceleration due to gravity on the surface of the earth? We say that on the surface of the earth, everybody around, every object around this surface of the earth experiences this acceleration due to gravity, which is 9.8. But for matters of calculation, we are going to convert that to, we shall round it off to 10. So if it is 10, that means that now here we have the value of acceleration due to gravity. So if you have this value here, it is measured in meters per second squared. We shouldn't be forgetting that, the SI units. So if we have that, which equation are we going to apply for this question here? So we see that we have the initial velocity, we have the time, we have the acceleration due to gravity, we have, now we need to find the V. So the question did not talk about the distance covered by the stone falling from the top of the tower. That means that any of these equations that have got displacement in them won't be applicable here. So we are going to use the first equation of motion under gravity to apply here for our question. So what is that equation we are talking about? We have it as our V. Our V is equals to so right now we shall have our V is equals to U plus GT. Someone might be wondering why we are not having it as V is equals to U minus GT. Why don't we have the negative, but instead we are having a positive? Because we are saying that this body is not going, it is coming downwards, and we are saying that acceleration due to gravity acts towards the center of the earth. And this stone is coming from the top of the tower to the center of the earth. You see that these two are moving in the same direction. This is our acceleration due to gravity G, and then this one here is our stone. So if it is moving at the same direction to also down, coming downwards, we give it a positive value. So that's why we are having our positive there instead of the negative. So what do we have? We can now write our equation as V is equals to, where there is U, we substitute the value of the initial velocity that was given to the body. So we know that our stone started falling with the velocity of 0 because it was at rest. So we shall have it here as 0 minus the value of acceleration due to gravity. For this case, we are taking 10. That is a plus. Let me eliminate this out. So if we have it like that, we shall have our V here. V is equals to what? Our U is 0 plus our acceleration due to gravity, which is 10. And then the time taken for the body to leave the initial position. It moved and attained a velocity that we don't know after 2 seconds. So we shall have our V is equals to 0 plus 2 times 10. We shall have 2 times 10 only, like that. So our V is equals to 20 meters per second, meaning that after 2 seconds, the stone attained a velocity of 20 meters per second. You see that it was at first having 0, because the more distance it was covering, that means that there is an increase in the velocity. That means there is speed, because without the speed it will not be falling. So After 2 seconds, the speed, the velocity it attained was 20 meters per second, and that is exactly what the question wanted us to find. So let us look at example 2. Example 2 is telling us that an object is dropped from a helicopter. If the object hits the ground after 2 seconds, calculate height from which the object was dropped. This time round, you see that they are not telling us to find the velocity, but they want you to find the height. Let me summarize it down. We have it as an object is dropped from a helicopter. If the object hits the ground, hits the ground, after 2 seconds, calculate the height from which the object was dropped. So if you look at our question, this time round it's not telling us to find to get the velocity that the body attained, but this time round we have to get the height from which the object was dropped. That means that we want to find the height of this helicopter from the surface of the earth. How far was the helicopter? Because if you know how far was the helicopter, then you will get to know the height there, whatever was dropped from, the object was dropped. So we can summarize our question, because they're saying the object is dropped from a helicopter if the object hits the ground after 2 seconds. They want you to find the distance covered by this object after hitting the ground in 2 seconds. So that means the timing was 2 seconds. We have our t, which is equals to 2 seconds. Calculate the height. They want us to find the height, mostly written as h. But in this case, what happens? If we look at our equations, we say that let's look at the second equation of motion and then the third. You'll see that it is s is equals to u t plus a half gt squared. This is the second equation. The third equation is 2 v squared is equals to u squared plus 2 g s. Have you seen any h there? The first one is v is equals to u plus g t. If you look at our question, our equations, there is nothing like h there. So which letter actually represents the height, the h in the equations? Here our height is equals to the s. So our s represents displacement, the distance covered. So in case you have it, you are written as h, then you're getting confused, you get to know that here our s is representing the height. So now we are going to take one of these equations to calculate that. It is still a positive because the object is coming downwards. The helicopter was already high, so it has to come from up there down, but not from the down moving to reach the helicopter. Let's see this. we have s is equals to that. We have this and this. Which equation can be suitable for that? So we shall see that we cannot use this. The first equation is not applicable. Why? Because our first equation here has got what? Final velocity. It has the initial velocity. There's acceleration due to gravity. And then it has the time taken. But the question wants us to find the height. So that means that we cannot use this because we don't have any height thing here to calculate. Let's move on to the second equation. What do we have in our second equation? Our second equation has the final velocity, it has the initial, and it has the acceleration due to gravity, and it even has the distance, the height we want to find. What is lacking in that? Because if you look at this, we cannot apply, and we cannot apply it in this question. This is because it is not explaining how long the body the object reached the ground. It does not have the time factor. So that means that we are also cancelling this. So this one is also off. Now we are left with one. This second equation is applicable because it has the height we want to find. It has the gravity. It has even the time. Because the question already explained to us, the object reached down from the helicopter at 2 seconds. So if it is like that, let's eliminate all these and we leave only the equation we are going to use. If we are using that equation, now our h is equals to the s. So it is the s we are finding. What again is here and we did not summarize it here? Acceleration due to gravity, we are taking it to be 10 meters per squared seconds. So if we take acceleration due to gravity there, that means that we now have the value of acceleration, we have the value of time. But look at this. We did not summarize what is the value of u, because if you leave u like that without a value, that means that you've got two unknowns in your equation. And when you work out an equation with two unknowns, what will you find the answer? That means that your answer will end up with also unknown, with an unknown thing there. So let us see. To eliminate the unknown, we try to find the value of this initial velocity. Because they are telling us that an object is dropped from a helicopter. Assuming this is my helicopter here. And then I want to drop this from the helicopter. How do I drop, assuming this is my object? That means that I'm just going to leave it from right here, from where the helicopter is, to just fall down. Meaning that the moment this one was here, on the helicopter or in the helicopter, it is at rest. It is not moving. It is the helicopter moving, but not the object. But the moment I release it from the helicopter, it's going to be falling down. So now after releasing it, that's when you see that the object is moving. Meaning that I have given it now a velocity. But at first, when it was just in the helicopter, it was already having an initial velocity, which is equals to 0. So we shall have our u here is equals to 0 meters per second. So now we have all this. Let's take all these values and substitute in our equation. We shall find it that our s will be equals to the value of u, which is 0. Let's substitute it there. Times t. What is our time? Time was 2 seconds for the body to hit the ground. So times our 2 here. Plus what? A half. Times acceleration due to gravity. What is the value of this acceleration due to gravity? We are taking it to be 10 meters per squared second. We have 10 times the value of time. Our time is 2 seconds, but in this case it was t squared. So we are taking it as 2 squared. What happens is we shall have s is equals to 0 times 2. What shall we get? We shall have 0 plus we have our a half times 10, then times, when you square 2, what will you get? That means that we want 2 times 2, which will give you 4. So we shall have 4 right here. So this time when you get 0 and add all this to 0, you will still get only those numbers. So we shall have our s is equals to a half times 10 times 4. So how would you eliminate the 2? We see that this 2 has common factor up. You can either divide it direct, or you first multiply the numerators and then divide it by the denominator. So let us multiply. We shall have our s is equals to 1 times 10 is 10, and then 10 times 4 is 40. So we shall have our 40 divided by 2. What is our 40 divided by 2? You see that 2 will divide 2, and you'll be left with 1, and then 4 divided by 2 will give you what? 2. So we shall have 2 and then 0. This is meters. That means that our object, right from the helicopter, came down to the ground at a distance of 20 meters. So it took the object 2 seconds to cover a distance of 20 meters. That means that by the time the helicopter was dropping this object down, it was already at a height of 20 meters from the surface of the earth. So now, if you have your question here, they were telling us to actually to calculate the height from which the object was dropped. Someone can also just tell you that calculate the height of the whole helicopter from the surface of the earth. So those two questions are actually the same. It is just different language used. So this is our answer there for the object. So for you to do calculations very well in our using these equations of motion under gravity, the first thing you need to know is the direction the object is taking. You see that here we also had a plus because the stone was thrown from up and then it's coming back down. And then if you come here, the helicopter was at a certain height. So if it was at a certain height, what happens is that the object was thrown from that certain height and then coming down again to the earth's surface, meaning that it is not moving against the action of the gravity. So we are using 10 here as our acceleration due to gravity, and in our first also we used 10 because we assume that these ones are at the same location, having the same altitude on the surface of the earth. Because if the altitude were different, that means the acceleration due to gravity would slightly change from the other. And it is 10 because we rounded it off. We know that the standard is 9.8 meters per second squared. So we can round it off to 10 just for the purposes of calculation. But if you use it as 9.8, it is also not a problem. It is still the same thing. So with that, we come to the end of our lesson. We shall meet again in the next lesson.